A very good afternoon to all of you. This is Yogen from Forsk Coding School. Please confirm if you can hear me. Okay, Shiv Harini, Deepika, Vishwajit Tripathi, Piyush, Pallavi, Agilesh, Danisa Fernandez, Anusaini, Viswal, Subhadra. Okay, so the guys all responding. Thank you. Okay, guys. So welcome again to all of you to Fast Coding School, and this is fourth day of our program. And if I say fourth day, this is basically the second last day of our program. We would be closing this series tomorrow evening. So, guys, what the agenda we have for today. And before I go on to that part, I want to know from you guys that can you please quickly summarize that what was the learning from yesterday's discussion, right? So what was your learning, from yesterday? So Sri Harini saying linear regression, okay, saying supervised learning, someone saying sklearn. Okay, Sandy saying linear regression, Kanishka saying how to train or fit the model, Swati Seth saying linear regression, okay, Pawan Kumar from Jamshedpur saying ML section, Vijay Mano, Neha Suresh, AI ML DL, Rehan Chaudhary, regression, Preetha Prasad saying philosophy behind ML, okay, Jaya, again, so people are now actually responding and happy to see their responses. Bobby saying best fit line, good guys, good, good. So label features, right? Scikit-learn library, okay. So just a minute, guys. Let me increase the volume. If I can increase the volume. Oh, yeah, it is down. Let me increase the volume. Yeah, I think it should be good now. So Piyush, is it good now? There was Pawan Kumar Jamshedpur saying, sir, I'm very happy with your lecture. Thank you, Pawan. Okay. Thank you, Piyush. So now again, guys, we have a new learning today as well, right? So what I'm planning to, uh, do now, guys. So I'm going to discuss what we are going to cover for today. See this. Today, guys, we are going to, learn algorithm for classification, right? So for classification, we are going to learn algorithm, and that algorithm would be called as KNN, K nearest neighbor, right? And along with this KNN part, I'm going to discuss one more generic concept that applies to regression, that applies to classification, right? So that applies to any machine learning problem solving. That concept is known as train test split, right? So guys, what I'm going to talk about today. So there is a concept which is called as train test split, and that's a very important concept in machine learning. So I'm going to discuss this part as well, what the meaning of train test split is and how we do it, and what we achieve when we do train test split. So that would be the case, guys. And once we finish this part, right, I will be explaining, we would be starting basically, and that section would be on unsupervised machine learning. So I will cover some part of unsupervised machine learning today and some part of it in tomorrow's discussion along with the DL. So tomorrow we are going to have a discussion around deep learning. And what I have done, guys, I have divided unsupervised machine learning into two parts. One part we are going to cover today, and the remaining part would be covered in tomorrow's. So Today, I will talk about the concepts, right? So the algorithm that we are going to discuss today under unsupervised machine learning is k-means. Don't get confused, guys. I'm talking about classification algorithm as KNN, and unsupervised machine learning, there is a algo called k-means. Okay, I'm going to explain where they fit, to each other. See this, guys. If you remember from yesterday's discussion, what we did, the tree kind of a structure that we created for understanding the ML better. So we have a machine learning here, and then we are having, two things here: a supervised machine learning and unsupervised machine learning. And when we are into supervised machine learning, the data set has, features as well as label. And from yesterday's discussion, guys, if you remember, right? From yesterday's discussion, if you remember, we were able to figure out that what the feature is and what the label is. Feature is basically, in terms of mathematics, this is independent variable, this is dependent variable, feature is X, label is Y, right? And in case of unsupervised machine learning, you only have features, right? You only have features and there is no label given to you. Now, under supervised machine learning, again, we have two, sections here. The one is called as regression, where you predict a number like salary prediction, population prediction, right? Kind of that. And now a classification. That is the second section where you, predict a class or a category, right? Like win or loss, right? And pass or fail, placed or not placed, right? And that would be there. Now, for regression, we have gone through an algorithm that is linear regression, right? So the algorithm that we discussed yesterday, that how to draw a best fit line, right? How to draw a best fit line, right? That was a discussion where we were talking about this algo. Now, there are other algorithms as well, but we are going to discuss this. So that is done now. And now we are in this section for today's discussion, guys. Here you have, again, a lot of algorithms. If you remember SVM, I told you, Naive Bayes, I told you, the, KNN, I told you the logistic regression, a couple of algorithms are there. The algorithm that we are going to discuss for understanding that how the classification happens, how to solve the problems from classification category. So we are going to use KNN, right? And now if you talk about unsupervised machine learning as well, guys. So unsupervised machine learning is also having two subsections. This unsupervised machine learning also has two subsections. The one section is called as clustering, that is known as clustering, and the other is known as association. Other is known as association. Okay, what the clustering is? Clustering means dividing your data into groups, right? Dividing your data into groups based on features only. सिर्फ features के basis पे, on the basis of the features only, if you can divide your data into groups, that concept is known as clustering. So let's say from this meeting room, if I can divide people based on their gender, right? So considering that gender is a feature of every human being, whether it's a female or a male, right? So based on that part only, I can divide into two groups, a male versus female, right? So just looking at the features, just by looking at the features, right? Because you have no access to the label. So by, you can divide that data set into multiple groups. That concept is known as clustering. And obviously, to perform clustering as well, we have a couple of algorithms, guys. And one of the best algorithm that works in this section is called as k-means, right? That is called as k-means. And there are other algorithms as well. DB scan is there, hierarchical clustering is there, right? So, but that is the most popular one. So I'm going to talk about k-means. I will introduce k-means today to you. I will talk about the mathematical philosophy around k-means, but we will actually, use k-means in tomorrow's practical solving, problem solving. Similarly, this category association, right? This is very much related to a term that is called as recommendation, guys. Recommendation, right? So how to understand this part, right? Guys, you must have been using Flipkart. You must have been using Amazon. You should be watching the videos on YouTube or like web series on Netflix or Amazon Prime or so on. Guys, when you look at some video on the YouTube, right? When you look at some video on the YouTube, you start getting suggestions on the right side, right? Similarly, when you buy some stuff on Amazon and Flipkart, you start getting, the recommendations on the right side. So if you go for buying a shirt, maybe there is a suggestion for you to buy a trouser as well, or maybe belt, or maybe a wallet, or maybe watch, or something else, right? And maybe you're going for an electronic item or electronic gadget buying. So correspondingly, you see the recommendations. And you must have experienced that these recommendations are different for different users, right? So how come a company, let's say e-commerce company, identifies that what to recommend, right? How to identify this list, how to create this list, right? So this list is basically dependent on lot many things. What you watch, what you like, what you dislike, right? What you have been buying in the past, what is your ticket size. Ticket size means kitna paisa kharch karte ho, right? So all of these things, right? Based on these things, we get these recommendations, right? So that happens in the category called association, right? And it is a quite complex world if you talk about. But the basic algorithm that is being used here very frequently is called as a priori algorithm. A priori algorithm. So guys, now I have listed you all of the sections from machine learning, right? Obviously, deep learning is not here. Deep learning would be, discussed tomorrow. So if you see, guys, now I have given you a complete chart regarding the ML. So how, where you have a supervised ML, where you have unsupervised ML, where you have regression, where you have classification, where you have clustering, where you have association, what are the various algorithms, right? So I'm just trying to, I'm trying to, give you the, algorithms here. And when you say, guys, linear regression, it has two, guys, when you say linear regression, it has two variations. If your data only has one feature, the way we had yesterday, right? Then this is called as simple linear regression, right? Simple linear regression. But if your data has more than one feature, that case becomes multiple linear regression. That cases. So I would be talking about a case where we will have more than one feature, and more than one feature can happen in regression, and it can happen in classification as well. It depends on the data, right? So guys, are you clear around this so far? Is that chart clear to you now? I think that should give you a very high level overview, a horizontal coverage that kahan pe kya cheezein hain, where you are right now, and what to achieve or what not to achieve. I think I have listed most of the things there, right? That's good. Okay. So whenever I say, guys, please respond, right? I'm not expecting that you will always say yes. You can say no as well, but at least respond whenever I say, what is your feedback, right? Right? Yeah. Thank you. Now, guys, first of all, before we go on to understand, the KNN part, I must tell you one concept that applies to regression, that applies to classification, everywhere. And that concept is known as, a train test split. Okay, let's understand this concept first, guys, because that plays a important role in solving any machine learning problem. So see this, guys, what happens. Guys, if you remember from yesterday's discussion, and let me show you the code from yesterday. And unfortunately, I lost that code yesterday, so I need to wrote it back. So guys, do you remember yesterday what we did? We did this. We imported a couple of libraries, right? And then we loaded the data. And from that part, what we did, we separated out the features and label. What was the feature for us from that data frame? So hours column became feature for us, and a scores column became a label for us, right? And after that, what we did, we imported the linear regression class. We created the object. That object is basically called as model in machine learning, right? And then we fitted the model. So fitting of the model means training of the model so that it can find out the best fit line for you, right? And once the best fit line is available, you can start performing the predictions. And that's what we did, right? Now, what you need to predict. So as a journal theory, guys, what you need to predict is your label actually, right? So if you want to predict the score, so your score has to be labeled. If you want to predict the salary, that means salary is the label. If you want to predict, let's say height, that means height is the labels, right? So what problem you're trying to solve according to your label, keeps on changing, and you have to understand from the problem statement, right? So, and it is, it may very well possible that, your label is in the first column and the features are in the, last, right? So never assume that label will always be in the last column, guys. Don't assume that you will always find the label in the last column. No, that is not a, that may change according to the problem statement, that may change, right? So guys, now you have to focus on this part at line number 39. Guys, what we did, we imported the class, we created the object, and what we did in the fit, we took the entire data set, right? We took the entire set of features, an entire set of labels, and we fitted all the data in this statement. But as a general theory in machine learning, right, there is a little variation here, guys. So abhi to humne just for understanding, because we were understanding how the things work for the first time. So what I did, guys, I just took all the features and all the labels and used all those features and labels. That means if you combine features and labels together, that will recreate your whole data set, right? So we use the entire data set to fit the model. But there is a little change here, guys, and that change is basically called as train test split. So how it happens, guys, let's see. Here, I'm coming to this part now. See, guys, we have a data set, okay? And from that data set, we are extracting the features and we are extracting the labels. And now we are using them in the fit method, where we are passing on the features and labels like this. So what the features are basically your X, and what labels are basically your Y. This is, a little variation here. So what happens, guys, let me explain you. So you have features and you have label from your data set, and you have extracted them, right? You have separated out them now. Now what happens, guys, rather than using the full set of features and labels to fit the model, we actually divide features into two sections, right? One section is known as train set and the other one is known as test. Similarly, we divide this labels as well into two parts. One is known as train and one is known as test. Okay, that means we are dividing feature into two subsets, right? So almost 80% is kept for training and the 20% is kept for testing. But this is not, hard. It can change. It maybe 70 is here, 30 is here, 60 is here, or 40 here. But you should never go, lower than 60%. And now, guys, basically this set which you are using for train is called as features train. So we will call it as features train. Okay. And we will call this as features test. We will call this as features test. Okay. Similarly, guys, same story happens with the labels. We call this section as labels train. Okay. And this section as a labels test. Okay. And now see this, what happens, guys. When we create the model, right? When we create the model and go for fitting of the data, right? You have imported the class, you have created the object. Now you're calling the fit method. In the fit method, rather than passing the features and label, now we pass this features train. We will pass the features train. And the corresponding, values of the Y component, right? The corresponding label is hidden here, guys, right? So if this is 80%, this will be 80%. If this is 70%, this will also be 70%. So split is same, right? So we are using a labels train here, guys. We are using. Okay. Now the model's training is done. The fitting has been done. Now we want to make sure that our model is working fine. The working fines means this model is giving the correct predictions. If your model is not giving you the correct prediction, it is of no use. But how to check, right? How to make sure that our model is giving right predictions, right? Our model is giving good predictions. So how to check for that? For that purpose, guys, what we do, we go for predict method. And now in the predict method, what I will do, I will pass on this test data, which is here into features test, right? So that 20% data that we have left, right? Because we only passed on the 80% data. So we are left with the 20% data. Now I'm passing this features test data. And obviously now it will give me the predictions that this is your prediction, this is your prediction, this is your prediction. So let's say there are 10 entries here, right? And then when we pass on this data, it will give us 10 predictions. So 1, 2, 3, 4, right? So these would be the predictions. So, some values would be there. And now how to check whether these predictions are right or wrong? So guys, if you see, this, is the features test. The corresponding values of the actual Y are hidden here, right? Actual Y values corresponding to this data is there. Right? So what we can do to make sure that predictions are good, we can compare these predicted values with what? Labels test data, right? We can, compare. So comparison happens here. And if these values are, right, these values are comparable, these values are close to each other, we say this is a good, a model. Okay, this is a good model. Okay, let me give you one more example, guys, right? Guys, so far, can you give me a feedback? Like, did you get this idea now? Did you get this idea now? Supreet Sani giving yes here. Vishmita Chaudhary giving yes here. Okay. Okay, so I will, explain, this one more time, guys. I will explain this, one more time, and don't worry about it. It will be very easy for you, right? So I'm just going to repeat this part first. So now, guys, what we do, we divide features into two sections. One section is called features train, other is called features test, okay? And similarly, we divide the labels into two sections, labels train and labels test, okay? And now what we are doing, we are passing features train and labels train, right, for fitting the model, right? And after fitting of the model, we use prediction, for features test. So we predict the values for this test data, and whatever the predictions we get, we compare them with labels test. Okay, why this is happening? Let me explain you. So let's say there is a teacher, Mr. X, in your class, okay, and he teaches your subject called data structure again, right? And Mr. X is actually referring a book which has 100 questions, and obviously corresponding to the 100 questions, it has got 100 answers. So for every question, there is an answer, right? And now what Mr. X does in your class, right? So for Mr. X, you guys are the model, right? You guys are the model, right? So what he does, he comes to your class, and what he does, he only picks 80 questions and 80 answers, right? So 80 questions, right? 80 questions here and 20 questions go here, right? Similarly, 80 answers here and 20 answers here. He divides them. And what he does now, he uses 80 questions and the corresponding 80 answers to teach you, so that you can understand what the data structure is, right? So he is now fitting in your brain what he's trying to fit on, that this is, the questions, and obviously according to the question, you will understand the, concepts and all. And then 80 questions and corresponding 80 answers are discussed in the class, so you can understand what the data structure, what the, stack is, what the, a queue is, what the linked list is, what that's in, trees and inverted trees, and, all these things. Okay, now he, after, teaching you in the class, now he wants to test you that are you getting the concepts clearly? Can you answer the new questions now, right? So what he does now, he does an exam for you, right? So that prediction is basically exam. And now what happens in the exam, guys? He asks you these hidden 20 questions which were not shown to you. So he does what? He asks you these 20 questions. And now what will happen? All of you will write, answers in the answer sheet. So corresponding to 20 questions, now you write answers, that this is the answer, this is the answer, this is the answer. And now how that teacher, Mr. X, is going to check whether you are understanding the concepts fully, right? Whether you do good in the exams, how to check? He will obviously check these answers with, the actual master key answers, right? So जो तुमने answer key में लिखा है, उसको किससे compare कर देगा वो? ये जो 20 answers यहाँ पे छुपे हुए हैं. Why 20 answers? Because corresponding to these 20 questions, the answers are here. So basically answers are labeled here and the questions are features here, guys. So guys, did you understand now that how the train test split is working? Right? So the exact philosophy, right? The exact philosophy, right, is a same. What the teacher is doing in the class, the same philosophy is being applied in machine learning as well. अब तो समझ में आया होगा, I hope, guys, right? किस तरीके से हम ये चीजें check करते हैं, how to check whether the model is working good or not, right? So that would be the case. So obviously I will use the train test split today in the coding part, and there you will understand more about it, right? Okay, guys, this split is completely random, right? So picking 80% data here and 20% data here, right, is a purely a random choice, right? It is just a it's just a random choice. So you can call the inbuilt method. We have a method that will help us in splitting this data. but you can write your own code as well. You can do that manually as well, right? So that is the concept, guys, about the train tensor split. And let me now, make it more clear about this concept when we go in a Spider and write. Let's see first what problem we are trying to solve today, right? Let's see first, guys, what problem we are trying to solve today. So see this, I have a problem for you. Okay, so there is a CSV file, but let me rename it first, right? It is written as C Caesarean 1. Just for a better, understanding, it is just, renamed as a Caesarean dot CSV. Okay, and now, guys, Pranav Rana, please keep this question for the last discussion. We'll answer that, right? Okay, guys, see this. We have a CSV file. Okay, what the CSV file is, basically this data is coming from a hospital, right? And what the data is all about, the data is from the what you say, uh, 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 from a department where the deliveries happen, right? So in that department, the ladies, when they feel labor pain, they get admitted and they have a delivery there. And see this, guys, what is happening. At the time of the admission, guys, they are performing couple of tests. So what they are checking for, that what was the age of the female when she got admitted, what was the delivery number, right? So delivery number, whether it was a first kid or it was a second kid, kind of that, right? Some delivery time it is talking about, but I have to check what exactly it is telling. Then they check the blood pressure problem, right? Ki blood pressure tha ya nahi tha, kind of that, right? Then they check about the heart problem, heart ka problem hai ya nahi hai, right? So after checking all these cases, right, and finally, right, once the delivery has been done, now they mark against every admitted lady whether she had a cesarean delivery or a non-cesarean delivery, right? So 0 means it was a non-cesarean delivery, and 1 means it was a cesarean delivery, right? So क्या बोला गया है इसमें, how to read this data? There was a lady with a 22 years of age, it was her first delivery, right? There was some, a blood pressure problem or not, kind of that, and right. So a couple of, tests were conducted, and finally, once the delivery was, there, right, it was a non-cesarean delivery, right? And, so guys, do you understand what the cesarean is? So cesarean is like, having a delivery through an operation procedure, right? It's not a normal delivery, right? So there was a guy who was asking this, what the cesarean is, right? Okay. So I think now you understand it, Praveen, what the cesarean is. Okay. So, this. So, guys, now, uh, you know, uh, guys, now what we have to do in this problem, now there is a new lady getting admitted, right? And let's say she is 25 years old, right? This is her first delivery, and a couple of other things like blood pressure or heart or all these things. Now, guys, can we predict whether it would be a cesarean case or a non-cesarean case? Can we make a prediction based on this data, right? यही तो machine learning है. So first we have to understand this data, and after that we have to make a prediction for a new patient whether she will have a cesarean delivery or a non-cesarean delivery. Guys, do you understand the problem now? right? Okay, now my question comes to you guys. Right? Will it be a classification problem or will it be a regression problem? What you say, guys? Sabhi log jawab dijiye, please. Will it be a classification problem or will it be a regression problem? So now a lot of people are saying it is a classification problem, right? Obviously, guys, it is a classification problem. Why it is a classification problem, right? Because if you see, guys, right, a 0 indicates a non-Caesarean and 1 indicates a Caesarean. That means there are only 2 categories in the label, right? Because what we have to predict, a case whether it's a Caesarean or it's a non-Caesarean, right? So last column is working as a label for us, and all of the columns, right? A is delivery time, delivery number, blood pressure, heart problem, they are working as a feature. So now we have more than one feature in the data, right? Age is one feature, delivery number is one feature, delivery time is one feature, blood pressure is one feature, heart problem is one feature. And lastly, we have a one column which indicates whether it's a non-Caesarean case or a Caesarean case. That means they are representing category. 0 means what? A class which represents, a non-Caesarean case. 1 means what? A class which represents, so it's kind of a yes, no, data. So now, guys, you can clearly understand that we have to predict a category, right? And then it has to be a classification problem. It is not a regression problem. Guys, is that clear with everyone? क्या ये ठीक है? सभी लोगों को समझ में आया? जवाब तो दिया करो भाइयों, है ना? Okay, good, right? So now, guys, to solve this problem, what we need to do now? First of all, we need to load the data, right? And once the loading of the data is this, right? Once we load the data, we need to separate out, right? We need to separate out the features and label, right? So guys, let's go into day4 day4.py, right? And how to do that, guys? Can we take some of the code from yesterday? Yes, we can take some of the code from yesterday, so at least we can import libraries from there. So we copy them and we just paste them right here. So see, guys, right? So that is see this. Right? So that would be the course. So we are done with this, guys. Now what we need to do, guys, we need to read the data. What the method we can use in pandas to read the data from this CSV file, guys? Read underscore CSV, right? So now we are going to do this, guys. Read a CSV, okay? And inside it, we are going to give the name of our file. So what the name is? Caesarean. So SAE. Okay, CAE actually, right? This is .csv. So that is the name of our file. And we are going to read this data in a data frame. So we say df is equal to this. So we have a data frame now, guys, with us. So we get this now. And now if you look at this, guys, we have a data frame, right? So age is there, delivery number, delivery time, blood pressures, heart problem, and finally a Caesarean column. And guys, now we can do a couple of things around this. We can get to know that what is the shape of the data frame. So how many rows and columns we have. We can, we see the 80 rows and 6 columns are there, guys, right? Similarly, I can go for, number of dimensions. It is a data frame, guys. So obviously it has to be a 2-dimensional data frame. So 80 rows and 6 columns, right? and we can know what are the data types for each column. So df dot d types, we have, now you can see guys, age is int, delivery number is also int, delivery time is also int, blood pressure, heart problems is int. So all of these values are integer, right? So see this. Now, how to guys, separate out the features and how to separate out the label. So guys, which column is the label in our case? Which column is the label in our case? Is it the last column which is the label here? Is it the last column, guys? Yes, it is the last column. So how to select the last column and assign it as a label? So I can go for, guys, do you remember we understood a method called iloc method? We understood a method when we discussed the data analytics on day 2, right? iloc method. So I'm going to use the iloc method here, guys. So df.iloc method. And if you remember, guys, using iloc method, you can make a selection of specific rows and specific columns, right? So now using iloc method, using a square bracket, using comma, before comma, you need to specify the row selection. So we need all the rows as of now. So I just say column. I am not specifying the start index. I'm not specifying the index, end index. That means it will select all the rows. That is the syntax from Python. After the comma, I need to specify the column, right? So can we use -1 so that we can access the last column, guys? Do you agree with me that we can use -1? Because -1 means the last value. It can be last column, it can be last item, it can be last row, right? So either I can use -1 or I can use 5 as well, right? So, I can use -1 or either I can use 5 as well as index, right? I can use 5 as well. And after that, I can apply dot values, right? Dot values. And if you remember, guys, why we are doing dot values? Because when you use dot values, it skips the index part, right? So labels is equal to, labels is equal to df this. Okay, let me go and explain this again, guys. See this, this is our data frame. And now from this, guys, this is 0, right? Index, this is 1, this is 2, this is 3, this is 4, and Caesarean column is at index 5. So I can either use -1 or I can use 5 as well. Both of the things will work, right? So if I do not use dot values, guys, then what will happen? I'm going to explain again this, guys. So labels has been there now, and now let me print the labels for you guys. 0, 1, 0, 1 kind of that, but index is also coming along with it. So to skip the index part, because that is not part of our actual data, right? So now if I say dot values, guys, I will only get the actual data. That is 0, 1, 0, 1, 0, 1. Now we understand what the 0 means and what the 1 means, right? 0 means non-Caesarean, 1 means a Caesarean case here. So that's here, guys. And how to get the features now, guys? How to get the features now, right? So to get the features, I'm going to use the iloc method again. And now in the iloc method, guys, I need to use this comma, and before comma, I'm going to use all the rows I need. Okay, now guys, can you give me that what should be my range here for column selection so that I can get all the features here? So guys, look at the data frame, right? 0 has to be there, 1 has to be there, 2 has to be there, 3 has to be there, 4 has to be there. So include the index 4 as well. You have to go up to 5, guys, right? You have to go up to 5. So what we can say, start from index 0 and go up to index 5, right? Why 5? Because 5 would be excluded. It will actually only consider 0, 1, 2, 3, and 4. So, right? So this way, we make the selection around the features, guys, and see this. Our features are now there. We get the features now. See this. We got the features now here. So 5 features we have. This is age, this is delivery time, delivery number, this is delivery time, right? this is heart problem, or like, some problems like, it was a blood pressure, or it was a heart problem. So a couple of things, right? So that was, so why to start from zero, Manisha? Because, if you look at the data frame, this is index 0, right? Because index column is added by pandas, right? Index column is added by pandas. So actual data is here. So age column is starting. That means this has an index 0, right? So this has index 0. And if you want to make a change, guys, rather than 5, you can say -1 as well, right? You can say this as well, because in that case, it will only skip the last column. It will take every column. Last से पहले सारे column को count कर लेगा ये, and it will only leave the last column. So you can do this way as well, or you can do this way as well. Both are, are fine in that case, right? Now, guys, we are, at features and labels are done with us. Okay, now what I told you guys, that now we have to perform train test split, guys. We have to perform train test split, right? The concept that I told you. And how to perform train test split? For that purpose, guys, we have already a method in scikit-learn. So I'm going to import that method. The method name is train test split, and we will use that to divide our data into features, train and features test, divide into a labels train and labels test, right? So guys, I'm going to import that. So from sklearn, right? Sklearn, right? Dot model selection has to be there. I think it is in the model selection. So sklearn dot model selection and import, right? Train test split, guys. So we are, getting this method now. This is there, guys. Okay. So now we import this method, right? See this train test split is there. Now, guys, what it will do? It will divide my features and labels into 4, parts. One part would be features train, other would be features test, then labels train, and then labels test. How to call that? Okay, so call that, we have to use this method name. So I'm going to use this, guys. We can do that. And now, while calling this function, guys, I need to give features and labels. तभी तो वो divide करेगा. पहले उसको data देंगे कि भैया इसको divide कर दे. So we are giving the features, we are giving the labels, right? And while giving the features and label, we have to do one more thing, guys. एक और चीज हमें करनी पड़ेगी. We will have to tell this method that which what portion to keep as training and what portion to keep as test. So we have to tell it that how much percentage you need to keep it as training and how much percentage you need to keep it as testing. So for that, I'm going to pass on a one parameter which is called as test size, guys. And when I say test size is equal to, let's say 0.25. What the 0.25 means, guys, that it will keep 25% for testing and 75% for training, guys, right? So it will divide the features and labels in such a way now that features train will have 75% of the features data, and labels train will have the 75% of the labels data, right? And 20% data, 25% data remains for testing. Okay, now it will give us the 4, set. So I need to, get this, this number is not fixed, guys. You can keep it 20%, you can keep it 10%, you can keep it 15%. That is up to you, that what percentage you want to keep it as a testing. But the ideal number should be around 20, 25%, 15%, right? That number is not fixed, right? So you can change that number. Now, guys, it will give us 4, things here, guys, right? It will give us 4 things here. What the 4 things it will give us? It will give us the 4 things what we mentioned here: features train, features test, labels train, and labels test, right? So we are going to use these names here. So features, train, पहला data इसमें आएगा, right? Comma, features test guys, right? So that would be, features test, okay? After this, the third value would be of labels train guys. So labels train, and the fourth value would be labels test guys. So that would be there. And now see this guys, I'm going to run this, and now you see, right? So we are done now, and now let me tell you that how many data we had in features guys. So what was the length of the features? See this, we had 80 records. Now can we check what is the length of the features train, because 75% data has to be there, so 80%, 80 ka 75% isme jayega, right? So now that is there guys, right? So 60 records came here, and now what would be the length of features test guys? See this, 20. So 60 plus 20 makes 80 again, right? Similarly guys, what about the length of the labels? Obviously that length also be 80. So we got this length, right? And what the labels train length? So see this guys, right? This is there. And then we have labels, right? Labels test. So guys, is my screen visible to you clearly? Is my screen visible to you clearly, right? So okay guys, thank you, right? And now guys, right? So that's there. Okay, now see this guys, what is matched? So we match actually features train, a features train and a features test, the corresponding values, right? So if X value is there in features train, the Y values would be find out in labels train guys, right? Isme rahengi. So if I can zip them together, you can see probably, maybe that is happening here. Can we do something like that? So, okay. So, okay, fine. So, oh, it comes out to be a what I can do then, maybe I can, rather than passing the, can I do something like that? Okay, ek baar dekhte hain. So, okay, I got it. So now you can see guys, this is the feature and this is the label, right? This is the set of features and this is the corresponding label. This is the set of features. So this is all training data we have, and similarly we can create a test data. Okay, now guys, is that clear that how we okay, if people are not you want to do the coding on their end, so I just going to paste it in their chat window as well, right? So I pasted this code in their chat window as well. So guys, is that clear? Features train, features test, labels train and labels test. हमने 4 हिस्से कर लिए हैं अब अपने. We have done the 4 pieces here, right? Now guys, मेरा problem क्या था, right? What was my problem, right? My problem was, so guys, this is not necessary that you all, you have to keep the names of these variables in that way only, right? You can keep any name. If you are comfortable with any other name, you can keep any other name, but we just want to retain the philosophy, right? That this is features and this is train data, this is a label, and this is train data, and this is test data. So we just to keep a a clean understanding. So variable naming convention has to be in such a way that by just looking at the variable name you can get to know, okay, this this is actual the data is, right? So that the cases guys, right? So that is there, right? So this is the case, right? So there is a third parameter, fourth parameter also comes, which is called as random state. We'll explain that later on. but that is not required as of now. So I have kept it minimum so that we get a clear understanding, right? Basic concepts are, should be clear first. Now, guys, right? So test of, test size is just a key value pair, guys. Test size is just a key value pair, right? This is the key, and then we are passing on the value. That's it, right? Yeah. Okay, guys, now because this is going to be a classification problem, right? So we need to apply a algo for a classification. And for applying the classification, I'm going to use KNN algo here. So guys, the way we imported a linear regression yesterday, we have to import the KNN here now. So now I'm going to import that from sklearn dot neighbors, right? So this is actually into neighbors. So sklearn dot neighbors import which one? KNN algo, and the KNN is basically called as K nearest neighbors, right? K neighbors classifier actually, right? This is called as K neighbors classifier, right? This is called as K, classifier. So someone said that my spelling is wrong. So let me check what is wrong with that. So, oh yes, yes, it has to be Z here, right? Okay, thank you guys. So it has to be. So, so now I think it should be fine, right? So see this, if we are successfully doing it or not, right? Oh, no module names. What's wrong with that? Okay, got it. So, and then it is, okay, so we have something wrong here, but we fixed it now. So now guys, we are done. Okay, now guys, right, see, I'm going to use this K neighbors classifier, right? And let me explain you that how the KNN actually, gives the prediction whether it would be a non-Caesarean case or a Caesarean case. Let me explain this part to you guys on the sketch pad. So see this, very interesting discussion coming up, guys. See this. So we are in the classification part, guys. We are in the classification, and listen, a very important discussion coming up for you. And we are using KNN here, and how the KNN works, understand that part. That is very important, guys, right? And after that, I will talk about one more, a concept that is known as confusion matrix, right? That is known as confusion matrix. Okay, see this, guys. Guys, your placement season is coming, for example, right? So I have some example from that perspective only. See this, guys. In a class, right? Let's say there are 20 students, right? For which I know about their two, kind of, information. On the x-axis, guys, what I'm talking about what is their communication skill, right? Communication skill. How about their communication? And on the y-axis, I'm taking the coding skill, guys. Their coding skill, right? So the communication skill here and the coding skill is here. So there is one student whose communication is poor and the coding skill is poor. There is one student whose communication is good, but the coding skill is poor. There is one student whose coding skill is good, but the communication is good, but the coding is very, very good actually. So I will keep this guy as here, right? So there is one candidate whose coding is good and the communication is also good. So on this side we are increasing the communication level. On this side we are increasing the coding level, right? So a couple of, points here, there, and now you can understand this, guys. So there, this is a distribution of the students now. And now, guys, against every student, right? Against every student, right? See, against every student, guys, I have a category that this guy is, placed, right? This guy is placed, right? This guy is not placed. Let's say this guy is, not placed. This guy is not placed. This guy is placed, right? This guy is placed, right? This guy is, let's say, not placed. This guy is placed, and this guy is placed. Okay, so every student is also given a category that this guy is placed or not placed. So this is the data I have. So that means I have a training data for you guys. I have a question coming up for you guys. So listen it carefully, right? So I have a training data for you. So placed, not placed, placed, not placed, this guys. Okay, now guys, there are two more students here. So one student is here. So one student is here, whose communication is this and the coding skill is this. So one student is here, guys, right? And one student is here, whose communication is this level and the coding skill is this level. Okay, guys, now you give me two predictions. That what should be my prediction for this student? Let's say this student is S1 and this student is S2. So for student S1, what would be your prediction, guys? Will it be placed or will it be a not placed? What is your prediction, guys? So now people saying, sir, P1 placed, right? P1 means S1 placed, right? And okay, and S2 not placed. Okay, how the KNN algorithm is used here to give this prediction? I'm talking about this concept, guys. मैं आपको बता रहा हूँ कि how the KNN takes the decision that whether this student would get a placement or not, whether this student will get a placement or not, guys, right? So how this happens? Basically, KNN, as the name suggests, K nearest neighbors. So it looks at the nearest neighbors, right? So let's say we keep the neighbors count, the nearest neighbors count is 3, let's say. So iska matlab, we are only looking at 3 nearest neighbors. So for this student, who is the nearest neighbor, guys? So let's say this one is the nearest neighbor, this one is the nearest neighbor, and this one is the nearest neighbor, right? So now for this student S1, you will see that there are 2 neighbors who are placed and there is 1 neighbor who is not placed, right? So we go with the majority because majority of the neighbors are placed. So I will also predict about S1 as placed. So that is the philosophy of the KNN, guys, right? So, and now similarly here, right, for S2, it will look for 3 nearest neighbors, guys, right? So this is 1 neighbor, this is 1 neighbor, and let's say this is the nearest neighbor. So for this guys, S2 guys, what will happen, guys? There are 2 neighbors who are not placed, and there is a 1 neighbor who is placed, right? And right, so this case, guys, in this case, guys, the prediction happens to be not placed. Okay, now guys, how to check that how many neighbors we should check for, right? So guys, that number K has to be odd, right? Keep this number odd actually, so that you never go for a tie. ऐसा नहीं हो कि 50% people are placed and 50% people are not placed. So, you will have a problem in giving the prediction. So keep this number as a odd, right? So if you keep K very, very low, then your prediction may not be very good because तुमने बहुत ही कम लोगों से check किया आसपास, तो तुम्हारा prediction may be poor. And if you keep K's value very, very high, then it will take more time for you to make it, a prediction. So you have to keep a fine balance, right? So generally the standard value of K is always 5. The standard value of K is always 5. So guys, is the concept about, clear to you that how the KNN is working? So obviously KNN takes the decision based on the nearest neighbors, right? And this is somehow very much related to your geometry or a physics problem, or you can say trigonometry. Why come this is very much related to geometry? Let me explain couple of concepts around KNN now, guys, that how to check for this distance, how to calculate this distance, or how to calculate this distance, right? Manisha, it is always good to keep the K as 5, right? So now, guys, see this. What about, I'm going to say now, let me explain a couple of concepts around, the KNN as well. So see this, guys, I'm coming to geometry now. This is our x-axis, guys, and this is our y-axis, okay? And now let's say there are two coordinates here on the 2D plane. So this is the coordinate P1 and this is the coordinate P2. It has got coordinates x1 and y1, right? So this is x1 and this is y1. And similarly, this has got x2 and this has got y2. So this is x2 and y2. And guys, most of in your mathematics discussion, what happens, guys? You calculate a distance from P1 to P2, and this is the distance that you calculate. What the formula you have, guys, when you calculate this distance? If you mark this distance as d, that what would be the d, guys? If you remember from that, x2 minus x1 square plus y2 minus y1 square and that square root. So guys, do you agree with me that this is the distance we keep, right? And this distance is basically called as Euclidean distance, guys. What do you call this, guys? Euclidean distance is called. समझ में आया नहीं आया बता तो दो भाइयों, right? This is called as Euclidean distance, right? Now, okay, there is a one more way to calculate the distance, guys. There is a one more way to calculate the distance. Okay, what I can do, I can first go horizontally up to this point. So I can mark this distance as x2 minus x1. And then I can travel vertically to reach to this point. So this distance would be y2 minus y1, right? So I can calculate this distance like this as well, x2 minus x1, plus y2, y2, minus y1, right? Maybe I can do this first. I can go y2 minus y1 first and then go x2 minus x1, but that distance remains same. That the sum would be same. Maybe I can do couple of delta x's first, then delta y, then delta x, then delta y, then delta x, then delta y, then delta x, then delta y, delta x, delta y, and similarly like this. But whatever the way you go, right? Whatever the way you go, this kind of distance will always be equal to x2 minus x1, right? So now you can see, guys, this kind of distance in mathematics is known as Manhattan distance. See this, guys, what you call this, guys, is Manhattan distance. This is called as Manhattan distance. And now while using KNN, right, we can specify the value of K. While using the KNN in code, we can specify the value of K. And we specify one more parameter, guys, that is known as P. If P is equal to 1, that means it will calculate the Manhattan distance, guys. And if P is equal to 2, then it will check for Euclidean distance. Guys, are you clear about these two parameters now? That while using KNN, हमें दो parameters की जरूरत पड़ेगी. One would be known as number of the neighbors, right? Number of the nearby neighbors. So we'll keep K as 5, and we can change P as 1 or 2 as well, right? So I'm going to use in the that concept now, guys. So कल हमने क्या किया था? We imported the class. Now we need to create the object. So how to create the object? By calling the constructor. Now while calling the constructor, I need to pass on two parameters. What is the K and P? So I will keep P is equal to 2, right? So I will keep P is equal to 2. That is my second parameter. But before that, I need to pass on the second parameter that is called as an neighbors, an underscore neighbors, right? So that would be the case, guys. And neighbors is equal to 5. So I will keep this. So, and this object would be, created and will, name it. So we need to keep a name here, guys. So I'm just going to say classifier, right? So classifier, yesterday's was regressor actually. So I'm just giving the name of the model in that way that it can explain whether it is performing classification or it's performing regression. So we create a model now, guys, right? This is the way we have created the model. Now, what happens after model creation? Guys, do we need to fit the model now? Yes, we need to fit the model. So what we do now, name of our model is classifier. Which method we call now, guys? Fit method. And now in the fit method, guys, we are, earlier we used to pass features and labels. But now after the train test is split, what we need to do, guys, now? We need to pass on the features train and labels train, guys, right? So this is what I'm going to do now. So classifier dot. So this happens, the training of the model, right? So training of the model is done, guys. And now I'm going to perform the prediction, guys, on my test data. So what is the test data we have, guys? What the test data we have? Classifier dot predict, and in the predict what we pass on, guys? आप बताओ क्या pass करते हैं? Features underscore test. We pass on the features underscore test, guys, right? And see, guys, now whatever the prediction it will give us, I'm going to store them with the labels, pred. Let's say that is stored in a variable called labels pred. So features test, कितने features test थे? 20 cases थे. उनके predictions कहाँ पे आ गए अब? Where we are storing them, guys? In the label spread now. And see this, guys, what is happening? Label spread. See, label spread. See this, label spread. See this, guys, right? So this is the prediction we have got. And now you can see easily, guys, that we have got the predictions. So let me, just keep it them here, guys. So what was my prediction for first case, guys? For which case? Let me print the features test for you. उसी के features test में से ही तो हमने predictions निकाले थे. See this, guys. So guys, these are the 20 cases. So for this case, where age was 24, and couple of other features are this, the model has predicted a 0 for us, right? That means it would be a non-Caesarean case. Details are here. The model has predicted 1. For this patient, right, the model has predicted 0, and so on. So we have got the predicted values. But how to check whether our predictions are right or wrong? How to check, guys? For that, I need to look at the values in the labels test. So what are the values in the labels test, guys? I need to print them. So labels test, देखते हैं उसमें क्या छुपा हुआ है. See this, guys. We have the values in labels test here. So let's copy them as well. See, the very important thing coming up, guys, just, focus here. So now see, guys, what is happening here. So we have a couple of values here as well. See this. Predicted that it was 0. Fine. For second case, now we are making comparison, guys, right? So for second case, the actual, category is 1. And my model also predicted as 1. So that means it was my, correct prediction, guys, right? So then I'm talking about this third case, guys. For this third case, the actual data says that it was a non-Caesarean case, right? And what was my prediction, guys? It was 0. That means it was again a correct prediction for me, right? So guys, in that way, if you see, right, we have 4 different categories, right? So this is the predicted data, guys, and this is the actual data. This is the predicted label, This is the actual label. For which cases? For these test cases. Guys, is that clear for you? Is that story clear as of now for you? And then I will introduce the concept of confusion matrix. Right? मैं एक बार वापस से रिपीट कर देता हूं क्या हुआ है. राइट? अरे बता तो दो, आया समझ में, आया नहीं आया, शुड आई रिपीट इट अगेन और लाइक यू नो आगे चलें? बताएं तो सही प्लीज. राइट? ओके ओके. ओके ओके. सो देखिए यहाँ पे क्या है. What we did, guys, right? What we did, right? So see this. We imported the class. We created the object, right? We fitted our model using feature strain and label strain, right? And then we perform the prediction on test data. So when you perform the prediction on test data, what you say, guys, you pass on the features test values, right? And what is the features test? These are the feature test values. Okay, and now when we go for a prediction, it will give us a prediction for every case, for this case, for this case, and for this case. So it will give us, the 20 predictions. So for, guys, this case, we have got a prediction 0, right? For this case, we have got a prediction 1 and so on, right? And now this is the predicted value. ये तो वो है जो स्टूडेंट ने आंसर शीट में लिखा है. अब वो आंसर शीट में लिखा हुआ सही है या गलत है, वो किससे चेक करना पड़ेगा? मास्टर की से. एंड हु हैज द मास्टर की? Labels, a test has the master key, guys, right? So labels test has the master key. So we have to compare these predicted values with the labels test. So what is in the labels test? हमने उसको भी print करके देखा. So that is labels test, guys, now, right? So we have copied and pasted here. And now we are just saying that for first patient, actually it was 1, but for my model predicted 0, right? For second patient, it was 1, model predicted 1. For third patient, it was actually 0, my prediction was also 0, right? For fourth candidate, it was actually 0, my model also predicted 0, right? For this candidate, actual was 1, but my prediction was 0, right? So now this way, guys, I will have 4, categories, right? I will have 4 categories, guys. See this. I will have 4 cases here. What are the 4 cases? See this. इधर तो लेते हैं predicted, right? So we take predicted here, and इधर लेते हैं actual. So we have the actual, guys, right? Prediction can only happen, so either 0 or 1 in the prediction is coming, or actual में भी 0 या 1 ही है. Okay, now guys, I'm just saying, how many cases were like this where I predicted 0 and actually it was 0, right? So वो number यहाँ पे आएगा. And that would be the correct prediction actually. मैंने भी predict 0 किया and actually भी 0 था, इसका मतलब वो match हो गया. इसका मतलब मेरा prediction सही था, right? And now guys, here as well, I predicted 1 and actually it was 1. वो भी तो सही prediction ही होगा. मैंने 1 बोला और actual में भी 1 था, इसका मतलब ये भी मेरा prediction सही निकला. Okay, what would be the other cases where I am predicting 1 but actually it is 0, right? मैंने 1 predict किया है लेकिन actual answer 0 है. That means it is a wrong prediction for me. Similarly, I predicting 0 and actually it is 1. मैं तो 0 predict कर रहा हूँ as a model, but actually में 1 है. That means वो भी mismatch है, वो भी मेरा wrong prediction होगा. So these are the only 4 cases as of now, guys, right? These are the only 4 numbers can have. So if you see, guys, these set of values are the correct predictions for us, right? And these set of values, so model कौन सा अच्छा माना जाएगा? जिसकी values ये वाली ज़्यादा हो और यहाँ पे कम हो, right? So now can, this concept is known as confusion matrix, guys. इसको क्या बोलते हैं? We call this concept as confusion matrix. And now, guys, right? Can you see my screen? Can you see my screen? So there was a guy saying screen not visible. Okay, fine, right? So ये confusion matrix है. Can we print the confusion matrix again? Can we print the confusion matrix again? Yes, we can print the confusion matrix again, guys. Right? हम चाहें तो confusion matrix को print कर सकते हैं. And for that, I need to import the confusion matrix. So first from sklearn, guys, dot matrix, right? Import confusion matrix. This is called as confusion matrix, right? So this is confusion matrix, guys. I'm going to import it. So ये मैंने import किया इसको. See this, okay? And now I need to call on this. So confusion matrix को अब call करते हैं. So call किया इसको और इसको दिया कि भैया compare कर ले मेरे data को. So comparison के लिए इसको दिया test data दिया, labels test, the actual data I'm giving, and then I'm giving the predicted data. So predicted data कहाँ पर छुपा हुआ है? Label spread. Why the label spread is the variable here? Because I stored all of the predictions in this variable only, right? So I'm going to use this variable. So थोड़ा सा छोटा कर देते हैं so that it's visible to you guys. So confusion matrix is, you know, getting the actual data and my predicted data so that it can make a comparison, you know, that which numbers, you know, are there in those 4 sections. What are the numbers, right? And now can you see, guys, we get 6, 1, 5, 8, right? So here we are getting 6, 8 here. So we are getting 6 here, 8 here, and I think here it was 5 and here it is 1. So now can you guys now clearly understand that out of 20 cases, 6 cases ऐसे थे, right? 6 cases ऐसे थे, guys, where, right, I predicted 0 and actually it was 0. इसका मतलब 6 cases में मेरा prediction सही था. 8 cases ऐसे थे, guys, जहां पे मैंने predict 1 किया और actual भी 1 था. इसका मतलब actually it was 1, so ये मेरा गलत हो गया, ये मैच गलत है मेरे, right? And 1 was the case where मैंने predict 1 किया लेकिन actually में 0 था. That is there, guys, right? And this way 6 cases are the wrong cases. So out of, you know, 20, 14 cases are correct, right? This is known as score of the model or accuracy of the model, guys. इसको हम लोग क्या बोलते हैं? Score या accuracy बोलते हैं, right? So guys, is the confusion matrix clearly understood by you, that what the confusion matrix means for you? इसको कहते हैं confusion matrix, और confusion matrix only happens in case of classification, guys. Always remember, guys, confusion matrix कब होगा? सिर्फ क्लासिफिकेशन के केस में ही होगा, राइट? क्लासिफिकेशन के केस में ही होगा. That is the case, guys, right? That is the case. Shivraj, इसको समझने के लिए simply, let's say you can easily understand the other way as well. Make example ले सकता हूँ कि how to understand the, a confusion matrix, right? This see this, guys, right? So guys, to be a model, we'll consider a model as a good model if the let's say it is 70% or 75%, score is 70% or above or 75% or above, it is considered as a good model. And guys, if you do the code out on your end, if you do, the code at your end, you may get a different values. Why the different values you will get? Because this train test is randomly splits your data, guys, right? This train test is randomly splits your data. And that's why the values may be different for you. This, this may happen, right? So, this gives us the random selection actually. ये randomly divide करता है test में और train में, right? So, yeah, Shivraj, right? So, this is the case, right? So you can play around with the value of k, you can play around with the value of p. Maybe you can keep p is equal to, you know, आप चाहो तो इसको थोड़ा सा change करके देख सकते हो that, you know, let's say you change k for 7, for example, right? And we use Manhattan distance, for example, let's say, right? We use Manhattan distance. So what will happen in that case, guys? We need to again run this code because we have made a change now. We need to fit the model again, guys, right? We need to fit the model again. We need to get the predictions again, right? And finally, we need to check, you know, with the confusion matrix, that what would be the case of confusion matrix here, right? So, you know, now you can see, guys, you know, do we get some change here? Is it 6, 8? Okay, it remains same as of now. There is no change, but maybe you can, you will finally get some values changed, you know, if you use p is equal to 2, for example, right? So, you know, things may be different, right? So, you know, that is, you know, it may happen. So now you can see, guys, right? We had a change here, right? So this time we are getting 5, 8 and 5, 2 here. So, you know, I think in most of the cases you go for Euclidean distance, right? In most of the cases, you know, you go for, you know, Euclidean distance, right? Yeah, you are right, Ayushman, right? So, you know, no Shri Harini, it is just k is representing कि आसपास के कितने neighbors को check कर रहे हो तुम. K is that representation, Shri Harini, right? K is that number that you are trying to check with the nearest 5 people, right? So that is there. So K5, K3 or K, you know, would be, so K means how many neighbors you are checking with, the nearest neighbors in terms of distance, Shri Harini, right? So that is there. It's not a number of rows and number of columns. It's just a how many nearby, you know, data points you are looking for check. So guys, did you get the idea around, you know, you know, so, you know, guys, Sanjmaya, and P here means, like, P means where you are using the Euclidean distance or you are using the Manhattan distance. So P is equal to 2 means you are using the Euclidean distance, right? And P is equal to 1 means you are using Manhattan distance, guys, right? So that is the case. So that is, you know, and this way, guys, you can, you know, way, and how to check for the accuracy. So 5 plus 8, guys, right? So 5 plus 8, you know, would be, you know, 13 divided by 20, right? So that gives you the accuracy. So that means as of now, your model accuracy is coming out to be 65%, right? You know, this is the case. So, you know, that is, you know, so Prithviraj Mohanty, we are not as of now going to discuss the validation set. It will happen in some future courses when we take some advanced topics in machine learning. And at that time, we would be talking about the validation. Generally, we take that in the deep learning, actually, right? We go for validation testing and all that in the deep learning, right? So, you know, that is the case. Yeah, you know, there are direct commands as well. You know, you can, you know, check through those methods as well, right? So model accuracy and everything is there. So guys, KNN का एक जो मैंने आपको एक overview दिया है, right? क्या वो समझने लायक चीज रही आज आपके लिए, right? Yeah, Vinay, you are right. Yeah. So that happens, you know, that is the case, guys. That is the case. Pranav Rana Singh, sir, can we increase the number of predicted values as compared to the number of our feature test? I did not get you, Pranav. क्या कहना चाह रहे हो तुम? So can we increase the number of predicted values as compared to the number. No, that has to be same actually, right? That has to be same, right? That has to be same. So Nilima Das, this is if you are using multiple linear regression, the code remains same. The code never changes. Only the number of features will change. And so I have told you that how to get more features, right? And then from day 3 code, you can exactly use the same code from here. Your just change will happen here, right? And this code remains the same. Nilima, right? Is code में change नहीं होगा. Even in the multiple linear regression, you use linear regression only. That is the method, right? Yeah, Shubhnil Bagchi, we will send the data in Google Drive for today, right? Yeah, Vinay Govikar, that may happen, right? If you increase the number of value for the k, you may get better accurate results, right? So that would be the case, right? And now guys, यहाँ पे similarly we can also check for a single prediction as well, right? यहाँ पे जैसे आपको ये हमने यहाँ पे किया था, so maybe we can go for a single a prediction as well, guys. Let's say you want to predict for this, right? So what you can do now, guys, you take X here, and these are the values of the patient, right? These are the values of the patient, guys, here, right? So this would be the X, guys, these are the values of the patient, right? And what is that? Oh, 2 equal to sign here. Okay. So now, guys, this is your axis, right? And now what we are trying to do, guys, we need to make a prediction, right? But X is a list. So what we need to do first, guys, we need to convert this into numpy, right? So we do this, guys, see this. Or X ka shape check karo. What is the shape of the X, guys? X dot shape. X ka shape kya aa raha hai? 5 comma. That means, guys, this is very important. See this, where the X is. Okay, see this. X is like this, right? It is telling that it has got 5 rows, right? But we need to have actually 1 row and 5 columns, right? क्योंकि हमारा data कैसा था, test data, या हमारा training data कैसा था, रो एक थी और इतने 5 features column में थे. लेकिन यहाँ पे क्या हुआ है, we have so many rows and there is only 1 column seen, right? So what we need to do, guys, हमें इसको क्या करना पड़ेगा, हमें इसको reshape करना पड़ेगा. So how to reshape that, guys? X dot reshape, right? X dot reshape. और क्या करें इसमें, 1,5, 1 row 5 column, right? It will look similar to what we used in training and testing. See this, guys, when we do this X, and now X is like this. अब हम इस पर prediction कर सकते हैं. Now we can perform the prediction on this, right? So now how to do the prediction, guys? Classifier dot predict, and we get the X. So that is the case where we do the single prediction actually, right? That is the case. And now you can see, guys, we get the 0. That means it would be a non-Caesarean case. So guys, ये समझ में आया कि single prediction कैसे करना है? How to do a single prediction? Did you get it? Right, guys? Okay. Right. So now, guys, we complete this way. We complete the classification part, right? We complete the classification part, guys, and 0 means a non-Caesarean and 1 means Caesarean. Bhargav, right? So guys, as I told you yesterday as well, the registrations for the certificates are open, and I think around 71 or 72 people have already registered for the certificates. So guys, you can also join that league now, and just go and register for yourself for the certificates now. and certificate would be given to you on Monday. They would reach to you by Monday, right? So that is the case, guys, right? And and obviously you need to pay 300 rupees to get a certificate, right? So that is the case. And so Bhargav, I gave this prediction inside the zero. It is coming as zero, right? So my prediction is coming zero, but the actually actual data is one, right? My prediction was zero, but actual data is one. That means it was a wrong prediction for me, right? Bhargav, ये जीरो यहाँ आ रहा है, इसका मतलब it's a non-Caesarean case. यहाँ one आता तो I would have predicted as a Caesarean case. So that is the case, guys, right? So go and register yourself for a certification, guys, and आज जो हमारी कहानी हुई है वो that was more focused on the classification part, guys, and what is interesting theory for you guys, right? Thank you, Padmavati. Padmavati says I have paid, sir. So what is more interesting, guys, that in the industry, right? In the industry, guys, most of the projects that are on machine learning, right? Most of the projects that are on machine learning, guys, they are mostly on the classification side. They are mostly on the classification. So 80% of the projects are on the classification side. Why on the classification? Because people are more interested in the final results, right? So जैसे कि क्रिकेट मैच हो रहा है तो people ask you first question, यार इंडिया जीती है हारी, right? And then they have a second question कि इसने क्या बनाया, कितने रन से जीती, कितने विकेट से जीती, क्या किया, ये किया, right? ऐसे, right? ऐसे ही पहले बच्चे से अरे प्लेसमेंट हुआ या नहीं हुआ, right? बाद में पूछेंगे CTC क्या हुई, क्या नहीं रही, कितना सैलरी रहेगा. That is the second question. That means classification question is coming first, and then you have the regression questions actually, right? So अरे ट्रेन टाइम पे आ रही है नहीं आ रही है, अगेन a classification. फिर आता है सर कितनी देर से आएगी, कितनी देर से नहीं आएगी, right? That is the kind of. So here even in the industry, right? So even in the industry, people are more on the Sri Harini. Sri Harini, okay. Sri, Sri Harini is saying, sir, can you give me a code for checking the accuracy? Okay, so Sri Harini ने ये कहा है checking accuracy, right? So let me go. मुझे नहीं पता है कि उसका कोड क्या होता है, right? So एक काम करते हैं, मुझे नहीं पता है तो कोई बात नहीं, नहीं पता है तो क्या करेंगे फिर? How to do how to do that part now? Okay, let's do one thing then. So I'm going here, guys. मैं यहाँ पे browser पे आया, right? So I'm on the browser now, and see this. यहाँ पे लिखते हैं checking accuracy, right? Checking accuracy from let's say a confusion matrix, right? Or like for classification, ऐसा करते हैं कुछ, right? For classification model, for example, right? एक काम करके देखते हैं. See this. Okay, metrics to evaluate your machine learning algorithms. So towards datascience.com is a good guys, site to go with, right? यहाँ पे बहुत सारे देख रहे होंगे आपको, you can get a lot of things here, and एक काम कर सकते हैं. Stack Overflow is there. Like, can you check the Stack Overflow, guys? Here, let's go for a Stack Overflow. How to find out the accuracy? See this, guys. So you have to check for this, green tick mark. That is the only answer where you can, actually, so guys, I think they are saying accuracy score is this way. So हम चाहें तो यहाँ पे इससे एक बार check कर सकते हैं. Can go here, accuracy score, guys. See this, we have the accuracy score here. Let me know what is coming this. Okay, a copy new. So we got this as copy and see the code here. Okay, we get the accuracy score. यहाँ पे हमारा रहा. And now I think accuracy score would require you to pass on this data. So let me check this here. इसको दिया हमने यहाँ पे and let's check for. So this comes out to be 65%. So Sriharini, is that okay with you? We directly have a method for classification where we can get the accuracy score, right? क्या ये समझ में आया guys? कैसे कैसे हमने so Stack Overflow should be your lifeline. You cannot remember everything. आप हर चीज को याद नहीं रख सकते और ना ही रखना है, right? So that is there. Okay, and now Sri Harini, I told you, right? I added a new person. See this, I added a new person, right? I added the lady admitted whose age is this 24, right? Delivery time is, delivery number is 1, then, some other value. So I have collected all that data. And now on this, I'm performing a prediction, right? So I converted that data into ND array, then I reshaped it, and then I finally performed the prediction, right? So that is the case, guys, right? Okay, now people are asking that what are the good sites for references, guys? So, maybe there is one site which is quite popular, Analytics Vidya, if you remember, guys. Analytics Vidya is there, right? A couple of, you can refer, so this is there, right? Alan, I'll come to that. Then we have Machine Learning Mastery, right? MachineLearningMastery.com. MachineLearningMastery.com, guys. See, this is also a very good site. This is there. Then we have one more, guys. KD Nuggets, right? KD Nuggets. वो भी काफी अच्छा site है. You can follow. This as well. There is a guy I'm very fond of him actually. So this is Sebastian Raska. Sebastian Raska. So this is the guy. A very good. He runs a blog. Sebastian Raska is there, right? And then Kaggle is also there. You can go on Kaggle. There are a couple of resources on Kaggle where you can check and study more. So this is there, right? So Vinay, you can use KNN, you can use SVM, you can use any algo, right? So even if it has more than 2 classes, no issues with that. You can use any algo as a classification algo, guys. So this is, guys. Okay, there is if you go to the YouTube, guys, right? If you go to the YouTube, there is a particular popular channel that is quite good in terms of machine learning content, and that explains you the mathematics part as well. That how things are there. I think that channel name is StatQuest, right? StatQuest. So StatsQuest करके एक channel है. वहाँ पे आप जा सकते हैं. And this is a very, very good channel actually, right? मुझे बड़ा so it gives you a lot of things around machine learning, right? And an explanation is very easy to understand. Very easy to understand. So I think the guy is very one of the best instructor I have seen actually. So मुझे लगता है आपको भी पसंद आएगा. So couple of resources I have told you, and I hardly refer any book actually, right? So if you're looking for a recommendation on the book site, you will get a disappointment, guys, because मैं book को बहुत कम refer करता हूँ, right? So yeah, Alan Joss. So book मैं बहुत कम refer करता हूँ. most of the time it is Google or blogs or YouTube channels or something like that and that. So that is the case, guys. So आज की कहानी कैसी, सही रही, समझ में आया? बताएं, फीडबैक दो, कुछ कहानी कैसी है आज की? How was the day for you guys? So Kanishka from Punjab saying great sir. Okay, Sanjay Saxena saying nice. Bhargav Ram saying amazing sir. Okay, Sri Harini saying sir it was good, amazing. Rehan saying all good. Yeah, Nishina, you can get it. Daisy Sharma saying fantastic. Okay, Saintan Saha from Bhubaneswar saying sir it was excellent, right? Mahak Gupta saying both the time. Pavan Kumar saying sir 65% समझ में आ गया मुझे, thank you Pavan, right? दोबारा देखो वीडियो जब तक समझ में नहीं आया पूरा, right? Shantoshini Hyderabad saying sir super cool. Praveen saying good bye. Thank you Praveen. Mohan Priya Kumar saying good sir. Kunal Patel, Kronal, okay, very interesting. Ayushman Mudgal, Pradeep Khatri, right? Alan Jones, you can plot this model, no issues about that, but that requires a little code, but वो अभी हम लोग इसमें नहीं करेंगे. That is very well possible, right? Vinay Govikar saying sir all 4 days awesome, right? Ashar Rahman is saying sir what is your GitHub? Okay, I will share a Forsk coding school GitHub with you. Patel, Deep Patel saying sir too good. Sri Harini saying sir your explanation is very clear and neat. Okay. Bharat Das saying sir awesome. Divya saying informative sir. Karthik Jaswal saying sir very good session, I will watch it again on the YouTube. Danisa saying sir it was fantastic. Sushrita Tripathi, right? Shivraj Karjagi saying sir good sir, actually I missed yesterday's class, continuous 4 hours sir. Okay. Bhargav Singh said doubt clarification is very good. Interaction is also very good. Hatim Rangwala, हम लोग कल कवर करेंगे अनसुपरवाइज्ड लर्निंग को, आज कवर नहीं कर पाए, राइट? अब मैं करूँगा स्टार्ट तो लोगों के ऊपर से जाएगा, बिकॉज अब हम लोग बिल्कुल लास्ट में पहुँच चुके हैं. सो मिस्टर अननोन सिंह सर समझ में आ रहा है, लेकिन कई बार कॉन्सेप्ट्स आर हार्ड फॉर बिगिनर्स. एक बार में समझ में नहीं आता है. But you can watch again, Mr. Unknown, right? What is your good name? Let me know. Rohit Pawar saying excellent sir from Mumbai. Preeta Prasad saying sir I am a non-programmer, have been undergoing many courses on AML, but this was the best in explaining from scratch. Thank you Preeta. Sushrita Tripathi saying sir please explain ROC. So ROC अभी इसमें कवर नहीं होगा सुश्रिता, मे बी इन सम फ्यूचर में हम लोग ROC AUC और ये सब लेंगे, राइट? सो Alan Joe Singh sir thank you sir, brand new information, right? Dreamer Singh sir can you suggest a good YouTube channel to study machine learning algos? I think the channel name that I have given you is StatQuest, Dreamer, you can follow that, right? Shubhanil Bakchi saying sir you are the best online instructor I have ever seen. तुमने देखा ही नहीं अभी Shubhanil मुझे, तो कैसे कह रहे हो कि I have ever seen? You must say ever heard actually. So Rehan Chaudhary saying sir out of all algos of classification which algo will give the most accurate prediction? So Rehan, this keeps on changing from problem statement to problem statement. In one data set maybe KNN is working best, on the other data set maybe SVM is working best, right? Pavan Kumar Jamshedpur saying sir what about unsupervised? That will take tomorrow, Pavan, right? Padmavati is saying sir session was good, right? Dr. Sylvester is saying, sir, we will extend Y one day. We'll check if required, we will do. Otherwise, we can close it by tomorrow, right? अगर ज़रूरत पड़ेगी तो maybe we can extend, right? Otherwise, we can leave that. So Bhargav, we will understand K-means tomorrow and the introduction to deep learning. कल जो टॉपिक है वो ये है कि एक तो K-means को समझेंगे, that how k-means is used in unsupervised machine learning to perform clustering and basics of the deep learning, right? So we have tomorrow we have a last day, right? So there, Sri Harini, we will try to that, right? So yeah, Vinita will understand the basics of the deep learning tomorrow, right? Basics of the deep learning, right? रोहित पवार नेक्स्ट वीक जावा का एक फ्री सेशन स्टार्ट हो रहा है फॉस्क कोडिंग स्कूल से, तो वो आप ज्वाइन कर सकते हैं। और उसके बाद पाइथन का स्टार्ट होगा 5 दिन का एक प्रोग्राम, यू कैन ज्वाइन दैट एज वेल, रोहित, राइट? सो रीमा, you need to go for projects only, right? Manisha, basically selecting a good algo for any problem, like you will have to try multiple algos and then decide which algo is working best for you, right? Working best for you, right? Vinita, KNN is the widely used one, right? शिवराज कारजागी सिंह सर, एक बार अपना वीडियो ऑन करें। I think it is not required, Shivraj, right? Right. So so that is, Shubnil Bakchi, Sylvester sir, can you share the calendar, please? Right. And Rohit, you can register yourself for upcoming sessions, right? Manisha, अभी advanced का शायद अगस्त में होगा, you can use that deep learning program maybe, right? So that is there.
So we have the calendar also on the Google Drive. So if these people go on the Google Drive, the calendar is there.
No, I think there is a link called bit.ly.forsk Forsk calendar. I think एक बार वो check कर लो, वो share कर दो. So what the assignment we have for today? Let me check what the assignment is we have for today, guys. Is that you are talking about delivery fleet? You are talking about, Alan? Are you talking about delivery fleet? Can you see my screen? Can you see my screen? I have given you that. So I think you were talking about this delivery fleet.csv, right? So basically this delivery fleet.csv file, contains the driving patterns, right, of the India. So what was the driver ID, how much distance he travels every day, what is the speeding a feature, like वो कितनी बार over speed करता है, on all that, right? So this is the data we have, right? This is the data we have, but I think this is not for today. It is for tomorrow, because that will come into clustering part actually, Alan, right? This code challenge is for unsupervised machine learning, Alan. I think that's why you were a little confused about it. सिल्वेस्टर सर, ये कोड चैलेंज दिया है क्या आज आपने?
सर मैंने वो day 4 अपलोड कर दिया था ना उसको, इसलिए उसने देखा है. I've deleted the day 4 there. So now the directory for day 3 and day 4 are same only, because this was the last day covered now.
Okay guys, तो आज का असाइनमेंट day 3 वाले में मिलेगा आपको. दर्शन, right? Please refer to day 3. So आज का जो असाइनमेंट है दर्शन, वो यहाँ पे guys, go for this day 3, वहीं पे है, right? So we have this day 3.
So आप भी रिफ्रेश करिए, बैक आइए सर एक बार,
right?
So we have only one directory for both the days, day 3 and day 4 now.
Okay. So now can you see guys, day 3 and day 4, like so so now you have assignment here. Darshan, क्लोज करें आज का guys. should we close it for today and see you tomorrow? कल मिलते हैं वापस से, राइट? 4 बजे मिलेंगे और कल नई और चीज़ें सीखने वाले हैं. Lot of new things coming up for tomorrow as well, right? Bhargav, I think we are looking for a couple of people who are good into ML already, right? हम कुछ लोगों को ढूंढ रहे हैं, 8-10 लोग चाहिए हमें जो already ML में अच्छे हैं. And there is a client who is looking for who is looking for people through our platform, right? So if you are interested, maybe you can apply for that. So I think soon you will get a message around that, right? Sylvester sir, can you share that वो link जहाँ पे apply कर सकते हैं? सुरेंद्र ने वो link दिया होगा internship वाला. Sylvester sir.
एक मिनट सर दे रहा हूँ.
Okay. So Bhargav, the link is coming right now on your chat window. Please wait. Huh?
शेयर कर दिया सर.
Okay. Take it. So this is the link, guys. Right. Okay, guys. See you tomorrow, 4 p.m. Bye bye.